I learned to ride a bike with training wheels. Sort of, but recent research shows balance bikes are a better way to learn. But the reasons why are important for learning multiple other skills. This 2023 paper had two groups of children. One group used training wheels and the other group used balance bikes. Over 10 sessions of 40 minutes, they tested 4 different parts of riding a bike. Starting, or self-launch, riding, or balancing on the bike, braking, and then full independent cycling. First, they tested the 25 children 1 week before the practice sessions. Then, over 2 weeks, they had 6 sessions with either training wheels or the balance bike, and then 4 sessions with a conventional bike. During the last 4 sessions with the conventional bike, they were tested to see if they were independent or not. But then they were tested again 2 months after the 2 weeks training. The same training was done in the same place, by the same teachers, in the same way, with the only significant difference being the training bike used. There was 1 teacher to 2 students, or in some cases, 1 to 3. And when we look at the results, the balance group had 100% success, whereas the training wheels group only had 75%. Due to COVID, the test groups were small, so this result isn't that significant. Only 3 children didn't learn to be independent. However, the balance bike group also learned the cycling milestones before the training wheels group. For self-launch, the balance bike group needed 1.3 sessions on average, compared to 2 sessions for the training wheels group when trying a conventional bike. For riding bikes, it took 1.15 sessions on average for the balance bike group, compared to 2.58 for the training wheels group. Then, for independent cycling, the main one, the balance bike group needed 1.42 sessions, compared to 2.92 sessions for the training wheels group. That is more than double the amount of sessions needed. So, although they all did 6 training sessions, those on the balance bike all learned to be independent, but could also all cycle the conventional bikes earlier, which begs the question, why? So in 2024, the same group published a second paper using the same methods to try and answer that question. Why? They added machines called inertial measurement units, or IMUs, on the children and on the bike, measuring things like acceleration and velocity. The machines gave the researchers the data about how the person and the bike moved during practice and the assessments. Their first measurement was before the training program. The second measurement was last, or the 6th training session. Then the third measurement was 2 months after the training program, so they'd been using conventional bikes. When we look at the results, there was more variability in the children's movements when using the balance bike compared to the training wheels. This makes sense, considering the training wheels are there to constrain movement. But the training wheels group moved the handlebars more, which, again, kind of makes sense because they can't really do anything else because the training wheels are constraining them from moving. Then we see reduced variability after 6 weeks training in the balance bike group, but increased variability in the training wheels group. And this is what the researchers expected because the training wheels group haven't really experienced how to balance before using the conventional bike because of the training wheels. The training wheels group learned to partially steer because some of the steering is restricted by the training wheels, but they didn't need to balance. On the other hand, the balance bike group needed to balance because there were no balancing aids. This could be why the training wheels group took longer to learn. The 6 weeks practice was too constrained. They weren't given the opportunities to learn how to balance on their own. But this goes beyond cycling. The paper mentions baby walkers potentially delaying babies walking, but more significantly for motor learning, this suggests highly constrained practice, so freezing the degrees of freedom, is less effective. Instead of breaking tasks down, learn to steer, then learn to balance, often done in isolated and blocked practice, simplify the task and keep the practice representative of the end goal. Practice the thing in context. In this case, don't remove balancing from the practice. Take away the wheels, lower the bike and get them cycling. The reasons why, when and how to use constraints is discussed in the constraints-led approach to coaching. But that approach is built on ideas from ecological psychology, which is a completely different way to look at the world. Mike Israetel recently argued against the ecological approach, and you can see more about that in this video over here.